Similar to the merge function, we have a join function. The join function in pandas takes into account the index to join. So let's say we have a left table with 4 columns and 1500 rows, and a right table with around another 4 columns and 500 rows. Now both these left and right table, let's for simplicity assume that have different column names. So let's say a new left table, left one, is equal to df dot ilog, and we take into account the first 1500 rows and the first 4 columns. Similarly, we can create a right table, right one, is equal to df.ilog, and we can say we take into account the first 500 rows and probably the last 5-6 columns. So let's say we'll take everything 7 onwards. Now if you look into the shape of the left one and the right one, we know that we have approximately 1500 rows and 4 columns. Here we will have approximately 500 rows and around 6 columns. Now if you do a join on these two data frames, they take into account the common functionality as the index. Let's say I would have a new data frame called join. I would say the left one dot join the right one. Now the default is a left join, so I will say how is equal to inner. When I execute this statement, I'll actually get a joint data frame with around 500 rows and 9 columns. So the 9 columns are the first 4 from left one, the remaining 5 from the left, the first 4 from the left one, and the remaining 5 from the right one. If I exclude this, or in fact I make it left, I can see that I'll have 1500 rows over here. That's it. That's the difference between merge and join. Join practically takes into account the index of the data frame. On the same ground, let's explore concat. Concat is a functionality where you can horizontally or vertically concat two data frames. So as simple as it sounds, let's create two data frames which we can concat. Now we have previously created a group data frame. Let's create that again. So we'll say df grouped 1 is equal to df.group by. We'll group it at the level for the variable sales, and we'll take satisfaction level as a summarized variable. I'm using the name variable and the column interchangeably. My apologies. So I'll say satisfaction level, and we create a mean of that. Just to be on the safe side and make it simple, we'll create as index is equal to false so that we have a column name. So we have df grouped 1, which would be the sales and the satisfaction level. Similarly, we'll create another data frame, df grouped 2, where we'll have the same terminology, but instead of a mean, we'll take the sum. It will make no mathematical or no business sense. I think just for demonstrating the functionality we have within pandas, I'm taking the sum functionality. Now the common thing between these two data frames is we have the same names for the columns. Now concatenation actually happens either vertically or horizontally. So vertically would mean that we have two data frames with 10 rows and 2 columns each. So the resultant data frame will have 20 rows and 2 columns. If it's a horizontal concatenation, it would mean that we have 10 rows and 4 columns. So pandas helps you provide the switch using the access parameter. So we can use concated is equal to pd.concat, and we can provide a list of data frames. It could be 1, it could be more than 2 also. So grouped 1 and df grouped 2. Now we provide the access parameter. By default, it will take access as 0. Let's have a look at access is equal to 0. We can see that the concatenated data frame will have a new shape. Let's say concated.shape. Here we go. So the data frame df grouped 1 and df grouped 2, both of them had 10 rows and 2 columns. and we are concatenating them on the axis, we have a resultant of 20 rows and 2 columns. Now, if in case we provide the parameter axis is equal to 1, so now it will do a column level concatenation, which means that it's a horizontal concatenation. Now if we check the shape, it will be 10 rows and 4 columns. This is how we simply go ahead and append rows to a data frame, or we horizontally concatenate two different data frames. These functionalities of a data frame, we will be leveraging them very frequently in our data engineering activities during exploratory data analysis and modeling activities. The last one, which I would like to showcase just before wrapping up pandas, is the pivoting functionality. So pivot is something which you would already be familiar with if in case you have already explored Excel. So pivoting would be, let's say a scenario, we have two variables. We have probably explored this earlier, but then let's take into account once again. So we're creating a new variable, new data frame over here. Let's say data frame PVT. And we are grouping this on two dimensions, sales and salary. Now with resulting data frame over here, df.pvt will have too many rows to actually go ahead and visualize. So if you remember, previously when we had such a lengthy data frame, I told you it's a difficult task going ahead and consuming this data frame. But this would have been easier if you have visualization in place. So if you go ahead and visualize this using a couple of the visualization techniques we have in Python, things would have been very simple. But alternatively, if we pivot this, things would have been very simple also. When I say pivoting, I mean if I enlist all the sales unique values vertically and all the unique salary values horizontally and appropriately assign the satisfaction level as a matrix, it would be relatively easy for me to understand and consume the results. So once I have the aggregated results, what I would do is I can say I'll create a pivot. Now the pivot is created as df.pivot2 is equal to df underscore pvt dot pivot. We provide the index. Index is the vertical column, which will right now be sales. Now the horizontal value, that is the columns, will be, in this scenario, salary. And the values over here will be the satisfaction level. Now if we create a pivot, you can see that we have a data frame of index with the sales, the column names as the salary, and the corresponding satisfaction level for each of this. So how do you interpret this? When the sales category is management and the salary level is low, the corresponding satisfaction level is 0.611. This is a much intuitive way to actually go ahead and consume results, and it's called pivoting. You pivot across an index and you pivot across a dimension, which is columns over here. Before doing a pivot in pandas, it's important to aggregate the values, because if in case if it encounters duplicate values, it will throw an exception. So in a nutshell, we have covered a couple of basic data manipulation activities, and we've looked into also a couple of few advanced data manipulation activities. So merge, join, concat, pivot, and group by are a couple of advanced data manipulation steps that we have explored in pandas. Overall, we've spent quite some time in pandas exploring what are the possible ways of augmenting and transforming data into new forms. This entire exercise will come in handy in the next sections while we explore data. Now that we have explored pandas, it's time that we go ahead and explore data visualization. The next section, we'll take a shot at doing data visualization using the native libraries in Python.